Okay, this is the exception. I start at r equal 1. There's r equal 1. 2 units above. 2 units above, I am at 3. And 2 units, oops. 2 units below, I am at -1. Let me go over that. If I start at 1 and I move 2 units above I am at 3. Move 2 units below, I am at -1. A graph of a sine starts at the origin, but it trends down. That's one full cycle. So, with respect to the original x-axis, I notice R switches signs between positive and negative. So I start this graph with, at 0, I am at 1. So this is one of those. Since R switches signs, it's one of those. I start at 0. This is 0. This is pi. This is pi over 2. 3 pi over 2 and 2 pi. So at 0, I am at 0. This starts decreasing. Before I hit pi over 2, it's going to zero out. So let me start from the beginning. At 0, I am at 1. This starts decreasing. Before I hit pi over 2, it's going to zero out. I need to know where that is. That's where section 3.4, I'm sorry, let me think which one was it. 2.3 comes in. Section 2.3, we solved equations, if you remember. That's when twice sine of theta equal -1. That's when sine of theta equals 1/2. Reference angle is pi over 6. And where's sine positive? Quadrant 1 and 2. Well, guess what? I just figured out that this point happens at pi over 2, and this point in quadrant 2 happens to be pi over 6. I'm sorry. Pi over 6 and 5 pi over 6. So which means by the time I hit pi over 6 and 5 pi over 6, by the time I hit pi over 6, that's going to zero out. Oh boy. How am I going to reach that? So I only need the pi over 6. Here we go. So this graph starts at, I only need the pi over 6 and the 5 pi over 6 for this graph. So this graph starts at 0, at 1. By the time I hit pi over 6, it zeroes out. Between, this is the most crucial part, between pi over 6 and pi over 2, R is negative. By the time I hit pi over 2, there's pi over 2. R is -1. If this is pi over 2, isn't -1 right there? So between those two, if R is positive, I'm in quadrant 1. If R is negative, I'm right there. So this is going to trace right there and hit that. Then what? Then it's going to come back. Still negative until I hit 5 pi over 6. Between pi over 2 and 5 pi over 6. If R is positive, I'm in quadrant 1. If R is negative, I'm in quadrant 4. Oops, wrong section. Between pi over 2 and 5 pi over 6. If R is negative, I'm going to come back and hit 0 by the time I hit this angle or this angle. Now between 5 pi over 6 and pi, I'm still in this quadrant. R is positive, increases. By the time I hit pi, I am at 1. There's pi, there's 1. And then after that, it keeps on increasing. By the time I hit 3 pi over 2, R equals 3. 3 pi over 2, 1, 2, 3. And then decreases back by the time I hit 2 pi, you are at 1. It goes back to the original starting point. What's crucial to know is that this loop starts at pi over 6 and terminates at 5 pi over 6. That turns out to be the most crucial part for us. Same deal with this problem. if I go to r equal 2, 1, 2, that is my vertical shift, and then 4, 1, 2, 3, 4, and 1, 2, 3, 4. Again, that's why it's really important to know where this traditional axis is. It's a must. So if I look at a graph of a cosine, starts on the amplitude. Again, I notice that r switches from positive to negative. So I know this is 2 pi. I know this is pi. I know this is pi over 2, and I know this is 3 pi over 2. Well, for starters, I'm not worried because at 0, I am at 6. I'm going to label those 2, 4, 6. That's simple. Decreases. By the time I hit pi over 2, so I start at 0, I am at, I forgot to label. We said this was r equal 2, r equal 6, and r equal negative 2. So at 0, I am at 6. Well, here I am. Decreases. By the time I hit pi over 2, r equal 2. Decreases. One of those. Now I notice I'm going to hit 0 before I reach pi. Between pi over 2, I'm going to hit 0 somewhere in there. No need to guess. Set this equal to 0 again, section 2.3. This is 1/4 that cosine of theta equals negative 2, or cosine of theta equals negative 1/2. My reference angle is pi over 3. And where's cosine negative? In quadrant 2, this will be 2 pi over 3. I just figured out that this is 2 pi over 3. And it is between pi over 2 and pi. And in quadrant 4, this is 4 pi over 3. So I know this is 4 pi over 3, and that's a must. So by the time I have hit 2 pi over 3, I really don't need this, and I really don't need this. I just need the pi over 3's. That's all I need. So by the time I hit pi over 3, I zero out. Well, by the time I start at pi over 2. By the time I hit 2 pi over 3, there's 2 pi over 3. I'm going to zero out right there. And then what? Now, r is negative between 2 pi over 3 and pi. By the time I reach pi, I am at negative 2. There's pi, and there's negative 2, you guys. So between those, if r is positive, I'm in this quadrant. But if r is negative, I'm in this quadrant. And that's where the inner loop starts tracing. And then I notice that I go back. Still negative between pi and 4 pi over 3. Between pi and 4 pi over 3. If r is positive, I'm in quadrant 3. If r is negative, I'm in quadrant 1. By the time I hit this angle, I hit 0 again. And then I continue on. Still between 4 pi over 3 and 3 pi over 2. By the time I hit 3 pi over 2, r equal to 3 pi over 2, 2. Right there. And then what happens after that? Well, after that, we know it keeps on increasing. And by the time I hit 2 pi, I am back to 6. There's 2 pi, there's 6. And there's the graph. So these graphs are really important. You should work at them. What if they play with the angles? Well, let's do one even, one odd. If I take r equal twice the sine of theta, well, amplitude is 2. Oops, that's okay. And negative 2. A sine wave starts at the origin, runs up, down, up. Now the beauty of this, I don't need to do much work. This is 2 pi over 3, the period. This is half of it. And this is half of that. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Well, the good news is, at 0, I am at 0. Increases. By the time I hit pi over 6, I am at 2. Pi over 6 is right there, and 2 is right, 2 is right there. I'm done. Oops. That's all I need. And reason for that, all of these graphs are symmetric. All of them. Which means it's going to take pi over 6 to come back. This is, now let's go back to that. We said if n is odd, if you notice, if n is odd, you get that many leaves, or that many petals. Since n is odd, n is 3, that indicates I have a 3-leaved graph. If I have a 3-leaved graph, guess what? Take 2 pi and you divide them by the 3 apart, which means wherever this happens, if I take this and I add 2 pi over 3, that's the next time it's going to peak. So if I take pi over 6 and add 2 pi over 3 to it, what do I get? That will be pi plus 4. That's 5 pi over 6. The next time this is going to peak at 5 pi over 6. Again, I use symmetry to my advantage. And if I add another 2 pi over 3 to this, that will be all over 6. That will be 2, 4. That's 9 pi over 6, which is 3 pi over 2. 3 pi over 2 is the third time it's going to peak. Oops. And that's how the graph looks like. Now I am running out of time, so I'm going to skip 54 and go straight to 56. Actually, I'm going to modify... No, yeah, that's fine. Let's do number 56. I'm running out of time. So let's do that. What do you do with a square? You ignore it for now. So this is what you do. You say, you know what? Forget that. I'm just going to graph r equal. Forget the square. A sine wave starts at the origin, runs up, down, and back to the starting point. And there it is. This is 2 pi over 2, which is pi. This is half of it. This is half of that. Right? And this is 3 pi over 4. So, all what I need is this part and I'm done. At 0, I am at 0. This increases. By the time I hit pi over 4, there's pi over 4. R will equal 1. Let's say this is 1. Oops. So, let's say this is only the circle we have. Well, this increases. By the time I hit pi over 4, I'm going to hit... Oops. Oh, come on. Last time will be a charm. But why is it doing that? Done. Now, if this is even, let's go back and look. If this is even, we said you get twice as many of those petals. So this is a 4-leaved graph. If this is a 4-leaved graph, that indicates, well, so that means they're 2 pi over 4 apart. Always 2 pi divided by the number of petals. Well, if this is pi over 4, and I add 2 pi over 4 to that, wouldn't that give me 3 pi over 4? That's the next petal. And another 2 pi over 4. And another 2 pi over 4. Oops. So the graph looks something like this. That would be r equal the sine of 2 theta. What does that square do? If you square root both sides, doesn't that indicate that this should be positive? So, this is the graph of r equal the sine of 2 theta. The graph of r squared equal the sine of 2 theta. What that does, that states, well, this has to be positive. Where's this negative? Look at the graph. Isn't that r equal 1 and r equal negative 1? Isn't it negative between pi over 2 and pi? Between pi over 2 and pi, if it's negative, you can't have that piece. And you end up eliminating this piece because those are symmetric. So, the square root eliminates half of those petals and you end up with just 2 petals. Alright? A tough section. There's the homework.